Hey class, today we are going to move on to day 2 of PVA, position, velocity, and acceleration. Position is a particle's position at any given point in time. Velocity is a particle's velocity at any given point in time and also the rate of change of the particle's position. Acceleration is a particle's acceleration at any given point in time and also the velocity's rate of change. Let's say the position function of a particle moving along the s-axis is given. T will be along the x-axis. S will always be measured in meters, and T will always be measured in seconds. Let's say, for example, we had 9 times t squared plus 2t minus 6. And let's say for part A, it tells us to find the velocity and acceleration functions of the original position function. Let's start by taking the derivative of the position function. In order to continue, we have to distribute the 9, which will end up giving us 9t squared plus 18t minus 6. Now let's take the derivative by bringing the 2 down and multiplying it by 9, which will give us 18t plus 18 since the t goes away and the minus 6 goes to a 0. This equals our velocity. Now to get acceleration, we have to take the derivative of the velocity function, which is 18. Now that we have our position, velocity, and acceleration formulas, we can continue to part B. Part B asks us to find the position, velocity, speed, and acceleration at time equals 1. To find the position at t equals 1, all you do is plug in the 1 for all of the values of t, then evaluate the equation. You repeat this for the velocity equation and for the acceleration equation. Since speed is just the absolute value of velocity, in this case it stays at 36. Now part C asks us to find at what times is the particle stopped. For this we need to use the velocity equation. First you set the velocity equal to 0 and then you solve for t. For all the values you get is at all the times that the particle has stopped. This -1 is either equal to a min or a max. Part D asks us, when is the particle speeding up or slowing down? To solve this, we have to figure out where the inflection points are by setting the acceleration function equal to 0. Since the acceleration formula is equal to 18, there are no inflection points since 0 does not equal 18. We now have to do the second derivative test to figure out whether the -1 we found in part C is a min or a max. Since the answer equals a negative number, the point is a minimum on our position graph. Since the left side of our point -1 is concave up, the particle's velocity is decreasing, and the right side is concave down, which means the velocity is increasing. So from -infinity to -1, the particle is slowing down, and from -1 to positive infinity, the particle is speeding up. Finally, part E asks us to find the total distance traveled by the particle from time 0 to time equals 5. All you do now is plug 0 into the position function and plug 5 into the position function, and then you add the numbers to get your total distance of 315 meters.